Good morning, students. So, today we'll start with our new chapter, that is quadrilaterals. You might have studied about quadrilaterals in your previous classes, what a quadrilateral is, how it is formed, what are its properties. So, in today's lecture, we will just be discussing about the basic terminologies related to quadrilaterals. First of all, uh, quadrilateral is any four-sided closed figure, right? So, if 4 points are taken in a line, that is 4 points are collinear, then if you join those 4 points it won't form a quadrilateral, right? Because obviously quadrilateral also has 4 points or four vertices, so joining these 4 points will not form a quadrilateral. It will form a line if these 3 points are collinear. On the other hand, if out of these 4 points, three are collinear and one point is non-collinear, then the figure or the shape formed will be a triangle. See, suppose these are the 4 points 1, 2, 3 and 4. These 4 points are collinear, and if I join them it will form a line, right? In the same manner, out of these 4 points, three are collinear and one point is, let us take this, is non-collinear. Then the line joining these 4 points will form a triangle, correct? So for any quadrilateral, it is compulsory that 2 points should be non-collinear, right? In this figure you can see, here we have this point and this point, these are collinear, and the remaining two, that means this and this point, these are non-collinear points. So to form any quadrilateral, it is important that 2 points should be non-collinear. Now if you join the opposite corners of a quadrilateral, then the line joining these quadrilaterals will be called diagonals. Now you are well aware of that quadrilateral has four sides, four angles, four vertices and two diagonals. We also know that in day-to-day life we encounter with many kinds of quadrilaterals. What many? Basically two or three types of quadrilaterals, that is square and rectangle. So let's next talk about angles and property of a quadrilateral. So in previous classes you have studied that the sum of interior angles of any quadrilateral is 360 degrees. Now in this we'll try to prove this. Okay, so consider this triangle A, this quadrilateral ABCD. Now as you can see, we have joint diagonal, we have drawn a diagonal AC joining the points A and C, right? This will divide this quadrilateral into two triangles, this one first and this is second. Now what we have to do is we have to observe these triangles independently. So let's first of all talk about triangle ADC. ADC, right? So in triangle ADC, you can see that angle DAC, let's name it as angle 1, angle D plus angle C, right? If we add these three angles, the angles and property of a triangle says the sum of interior angles of a triangle is 180 degree. So angle 1 plus angle D plus angle 2 will be 180, right? And in the same manner, in triangle ABC, let's say this one is angle 3, this one is angle 4, this one is angle B. So angle 3 plus angle 4 plus angle B will be equals to 180 degree. Now if you add these two, suppose this is equation 1 and this one is equation 2, if you add these two equations, what you will get is angle 1 plus angle 3 will form angle A, angle 2 plus angle 4 will form angle C, and angle B plus angle D on the LHS and RHS will become 180 plus 180, that is 360. So adding 1 and 2, it means equation 1 plus equation 2. So angle A plus angle B plus angle C plus angle D will be equals to 360 degree. This is the basic proof regarding the sum of interior angles of a quadrilateral. Now let's move ahead to types of quadrilaterals. So here we will be discussing about 6 types of quadrilaterals. The first one is trapezium. Right, first one is trapezium, second one is our parallelogram, third one is rectangle, fourth is a rhombus, fifth square, sixth is a kite. Now let's see the basic definition first of these 6 geometrical figures. In case of trapezium, trapezium is a type of quadrilateral in which opposite sides are parallel, right? And in case of parallelogram, opposite sides are parallel, both the opposite sides are parallel, but in case of trapezium only one side is parallel and other two sides are non-parallel. And third is a rectangle, which is a type of parallelogram having each angle equals to 90 degree and opposite sides also equal. In case of parallelogram also opposite sides are equal, that means this side SR will be equals to PQ and QR will be equals to SP. So rectangle is a type of parallelogram having each angle equals to 90 degree. And let's first talk about figure 5, that is a square. Square is a type of rectangle having all sides equal. Now fourth one, it's a rhombus, right? Rhombus is also a type of parallelogram having opposite sides parallel, but the difference in rhombus and a parallelogram is that in parallelogram opposite sides were equal, but in rhombus all four sides are equal, right? Now, this is the last type, which is a kite. So in kite is not a type of parallelogram, but we can say that kite is a type of quadrilateral having adjacent sides equal. So what in this chapter we will study is about various types, not various types, we will study in detail about the parallelograms. What are the properties of parallelograms? There are some major theorems. So to solve these theorems, you should be well aware about the chapter triangles, which is related to congruency.